Hello everyone, my name is Julio and I'm going to present our work about the sleep detection that I carried out together with Professor Pablo Gil at the University of Alicante. This work is about implementing a system that is able to measure the angle of rotation produced by slippage using the vision-based tactile sensor known as Digit, that only generates an RGB image, instead of using other tactile sensors that generate richer information such as visual markers or force values. Reviewing the literature, we didn't find any dataset related to tactile segmentation, so we created our own dataset using 16 objects from the ICB dataset. We also used other household objects for the experimentation of measuring the angle of rotation. Our method is made up of two stages. In the first one, we can choose among 3 different CNNs to segment the region of contact between the object and the sensor. In the second stage, we use this segmented region of contact to estimate the angle of rotation choosing among 3 different algorithms such as PCA, ellipse fitting, and skeleton thinning. Finally, we divided the experimentation in 2 parts. First, we evaluated the performance of the 3 CNNs with the test set of our dataset, and we observed that the 3 architectures are suitable for the task of tactile segmentation. However, we decided to choose the deep learning model because it is a little bit faster. With the deep learning model, we evaluated the 3 different algorithms to estimate the rotation angle, changing the size of the window filter that we use to reduce the noise of the camera signal. In these 3 graphics, it can be seen that the skeleton method gets lower error and deviation for every window size compared to the other 2 methods. Now I'm going to show you 2 quick videos in order you to see how our system works. Here you can see in blue color the predicted angle by our system, and in orange color you can see the ground truth angle that we calculate using the 2 Aruco markers that you can see in this video. So thank you very much for your attention.